Hello everyone, and welcome back to a new episode of, I was about to say Dungeon Crawl Stone Soup, but no, it's Advent of Code 2016. We're going to do problem 18 and be all caught up for tomorrow's puzzle, the 19th. Day 18, like a rogue. As you enter this room, you hear a loud click. Some of the tiles in the floor here seem to be pressure plates for traps, and the trap you just triggered has run out of whatever it tried to do to you. You doubt you'll be so lucky next time. By the way, like a rogue, I told you, this guy is a fan of roguelikes, right? We've had all these, like I was just saying in the last episode, gosh, there's an awful lot of things that have a map where, like, a hash is a door and a period is a floor and, like, blah, blah, blah. And then he says, like a rogue. And there's traps, and they're indicated by, of course, what else? Carrots. That's what a trap should be in a roguelike. Anyway, upon closer examination, the traps and safe tiles in this room seem to follow a pattern. The tiles are arranged into rows that are all the same width. You take note of the safe tiles, dot, and traps, caret, in the first row, which is your puzzle inputs. They're giving us the first row. And so I've already read this. I'll just summarize for you. For each row, each row has some traps and some safe tiles, and which is determined by the previous row exclusively. This is like kind of a classic cellular automata kind of thing, I suppose. A one-dimensional cellular automata, although like the Game of Life is famous as a two-dimensional cellular automaton. Blah, 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 blah. So basically, each tile looks at the previous tile above it and the ones to the left and right of that. So 3 depends on B, C, and D. 4 depends on C, D, and E. 5 depends on D and E, and also this like sort of imaginary tile to the east of that, which is considered safe since it's out of bounds. There's no trap there. And based on which of those are traps versus non-traps, there's a rule telling you whether the tile you're thinking of should be a trap or not. So basically, if the left and center are traps, but the right isn't, then yes. If the center and right are traps, but the left isn't, then yes. Or if only the left or only the right is a trap. So first thing to note is that this should be 50% traps, right? There are 8 possible ways for the previous 3 tiles to be distributed into traps and non-traps. And in 4 of those conditions, we have a trap, and in the other 4, we don't. Okay. The second thing to note is that actually we can just completely ignore the center tile. Basically, if either the left or the right, but not both, are traps, then this should be a trap. Right? That's basically it. That's the whole thing. So if they're... In fact, since we're going to be working with this as strings rather than as booleans, we can say if the left and the right on the previous row are different, then this should be a trap, and if they're the same, then it should not be a trap. So here's an example. You know, we could follow the rules to see why this is true. And in fact, let's. So here, the left and right tiles are the same, i.e. the one left of the grid is safe, and the one right is also safe, so the result is safe. Here, the right tile and the left tile are different, so we get a trap. Likewise here, the right and left are different, so we get a trap. And like the same thing applies here. Fine. So starting with the map in your puzzle input, in a total of 40 rows, including the starting row, how many safe tiles are there? So I think that, well, let's go get our puzzle input. It's exactly 100 characters, which is exactly... Actually, I guess it's 99 characters? And the 100th character... Alright, anyway, whatever, it doesn't matter. just happens to fit exactly on my 100-character wide Emacs instance. Okay, so a thing that we want is we want iterate again, but we don't. We can actually hard code it to be the one function we'll be iterating. So we'll just say step. Let's just call it rows. In fact, start. Basically, first actually. While true, we first yield start, and then let start equal next of start, which is a little bit exciting. Next of start, and let's def next of a row to be well, let's first let row equals, well, let's say previous equals row. So rather than try to remember that we need to consider out of bounds tiles to be safe, let's just create those out of bounds tiles and mark them safe, and then we can treat. We don't need any boundary conditions on the edges anymore. And basically, we'll just return nothing.join of previous of I minus 1 equals previous of I plus 1. I plus 1. If so, if they are equal, we return a dot. If else, hash. For I in X range of len of row. Yes? So let's try that real quick. Next of, hang on. You guys haven't looked at any of this, have you? All right, here you go. There it is. It's been a while, hasn't it, since I forgot which screen to show you guys. I've been getting better at it. But so, I hope you guys enjoyed that little trip down nostalgia lane. We didn't write anything very exciting. We wrote rows, which is basically just iterate with the function hard-coded as next. And in fact, you know what? Let's call it iterate of x f. So we'll, we might have a different rule for computing traps, for example, right, in part 2. And it'll be nice to have a general iterate. And then I wrote next, where, as I mentioned, we are creating the outside tiles, so that we can just look them up by index rather than having to treat that specially. And then we're just saying we're creating this generator here, which is a safe space if the previous left and right are the same, and otherwise a trap for every I in a range for len of row. Okay, so let's test this on a sample input. Grab that. I don't know why I showed you guys me grabbing that. It's not very exciting. Next of this, please. It's not the right answer. Why is it not the right answer? Okay, let's try it on an even smaller result. Copy this. Next of like this, please. Why? What am I doing wrong? What is next of this? What should it be? It should be nothing, right? No, it's wrong. Why is it wrong? The left and the right are the same. They're both emptiness. Right? Yeah. So clearly I'm doing something wrong. For I in X range of len of rho. I feel like that must be what I'm getting wrong somehow. So for I, well, no, because we have the right number of things, right? It's 0. Oh! Aha! So the problem is, we're looking at the 0th element. So the problem is that the new row we created is wider than the sort of pseudo row that we're pretending the previous row was is wider than the previous row actually was. So we just need to add 1 to all the indexes, basically, and then we should be okay. Is that one right? Yes, that's right. Okay, great. And so now what do? We can just write start equals sys.stdin.next. What? That's .rstrip, I guess. Rows equals iterate next of start. Print sum of s.count of trap for s in islice rows. How does islice work? Help of itertools.islice. It wants a stop as its main argument, supposed to pass 40. Oh, whoops. Caret, please. Okay, that looks good. So let's try running it. Python source.py input. 2013. Oh, but we actually wanted to know how many safe tiles there are. Well, of course, we could have subtracted that from 40 times 99 or whatever. Or from 4,000, I guess. Yes, this goes to my browser. How many safe tiles? 1987 is the right answer. Very good. Return today. Here we go, and let's see what part 2 is all about. How many safe tiles are there in 400,000 rows? Oh, well, that's easy, right? Right. Let's just git commit this, git add day 18, part 1. Past few days has, no, this day anyway has seemed pretty easy. Some of the recent ones have, but not all of them. Def solve of rows. Well, actually, let's say init num rows to be return. Well, actually, return this sum of s dot count for s in itertools.islice of iterate of next of init num rows, right? That looks good. Print solve of start and 40, part 1, %d, and then we'll just do part 2 in the same way, but with 40,000, right? Still got the right answer for part 1, and here's part 2. As expected, by the way, it's very close to half of the total area. The answer is too low. What? $400,000? Did I type 40,000 instead? I did. All right. So we have to wait a minute before we can submit. We'll just use that time to do some git cleanup, assuming that it finishes in a reasonable amount of time, which it should. Okay, great. Well, let's copy this. Git add day 18, part 2. Pretty simple. Not much going on there. I have 12 seconds left to wait. It didn't even take me a minute to rerun it and do my git commits. Well, anything else I should do? Git status. No? Boy, this is such a simple problem. Like, it can't be that the trick was to notice the XOR thing. That seemed pretty simple. I'm sure everybody thought of it. I don't know. So that seems like it took me 12 seconds to think, right? That's the right answer. We got a gold star, guys. You guys have accidentally been looking at the browser this whole time, but I think it was about as interesting as as the code, since I wasn't really doing much. Yeah, so I don't know, not much to say about this one. We just used slice and iterate, and it's easy. We didn't have to hold anything more in memory than necessary, and right, we're only holding one line in memory at a time, basically. Yeah. The most complicated thing was that we did this wrong, right? The function to compute the next of the row. That was hard, I guess. Anyway, nice, easy one. I thought this was going to be a bit longer. Maybe the part 2 was going to be a little more of a twist rather than just a different number to use. I don't know. So that's it. Nice short episode. Hope you guys enjoyed it. Thanks for watching, and I'll see you next time.